So we're digging into Nvidia CEO Jensen Huang's talk at the World Economic Forum. And, usually these Davos interviews can be a bit of a victory lap. But looking at the transcript, he's not really there to pitch a new chip.
Yeah.
He's outlining a complete industrial pivot.
Oh, it's way more ambitious than that. He frames this as the fourth platform shift.
Okay, so we had the PC, the internet, mobile cloud.
And now this, where he says the entire computing stack is being reinvented from the ground up.
And he used this great analogy to explain it, this 5-layer cake.
Right, and most people just see the frosting, the apps. But the first layer, the foundation, isn't even code.
It's energy.
It's energy. I mean, not just plugging in a server, but energy at the scale of a small country. He basically argues that you can't have intelligence without the raw electrons to power it.
That's a huge bottleneck right there. So, okay, energy is layer 1. That supports the chips, then cloud infrastructure, then the AI models themselves.
Exactly. And only then, at the very top, you get layer 5. The applications. That's where all the economic value actually happens in healthcare, finance, everywhere. But you have to bake the entire cake first.
And that bottom layer, the physical stuff, is what's driving what he calls the largest infrastructure build-out in human history.
Yeah, and that's the investment thesis for the real world. We're talking chip plants, computer factories, massive data centers all over the globe.
Which leads to this kind of paradox, where the first big winners of the AI boom might not be coders.
No, not at all. It's a renaissance for the manual trades. Electricians, pipe fitters, welders. Huang says if you can physically build the machine that builds the intelligence, you are in high demand.
And the salaries are hitting 6 figures for these jobs.
Because there's a massive shortage.
Okay, so you have this enormous physical build-out, steel, concrete power lines. But then what's running inside these new factories is where the software rules completely change, right?
That's the core of it.
Yeah.
The shift from what he called pre-recorded software to actual reasoning.
What does that mean, pre-recorded?
Well, think about old software. It lived and died on structured data. If your data wasn't in the perfect row and column in a SQL database, the software was basically useless.
Right. It couldn't handle any ambiguity.
Exactly. Now you can throw it a messy PDF, a blurry photo, a voice memo, and it just figures out the context. It doesn't need those neat columns anymore.
And that leads to what he calls physical AI, which sounds like science fiction.
Well, this is the part that really matters for science and engineering.
But hold on. Haven't we always used software to simulate physics? I mean, weather models have been around for decades.
But that's the key difference. We used to write very strict equations to simulate the weather. We told the computer the rules.
Okay.
Now they're feeding the AI raw observational data, and the AI is learning the laws of physics and chemistry on its own. It's not simulating our rules, it's creating its own understanding of the world.
Which is how you get to that Eli Lilly partnership you mentioned. The AI isn't just crunching numbers, it's talking to proteins.
Precisely. It accelerates drug discovery because the software genuinely understands the physical rules that govern how molecules behave.
So if AI can understand biology, naturally people start to worry about it understanding their jobs. But Huang has a framework for this, doesn't he? The whole task versus purpose idea.
Yes. Look at radiologists. A decade ago, everyone was saying AI would replace them because a machine can read a scan faster.
But today we have a shortage of radiologists. We need more of them.
Exactly. Because reading the scan is just a task. The purpose of a radiologist is to diagnose disease, to talk to patients, to create a treatment plan.
So the AI automates the task, which frees up the doctor to focus on their actual purpose.
And productivity skyrockets, costs go down, and the system can ultimately treat more people.
Let's shift to the geopolitical angle for a second. He brought up this concept of sovereign AI.
I thought this was fascinating. He argues that AI is a national utility, just like electricity or roads. You shouldn't just import your intelligence from Silicon Valley.
So every nation needs to build its own.
Its own AI, using its own data, reflecting its own language and culture.
But what's interesting is he thinks this actually closes the technology divide for emerging markets, which sounds counterintuitive.
It does, but his logic is that the barrier to entry has just collapsed. You don't need a computer science degree from MIT to build things anymore.
Because the programming language is just human language.
Right. You just prompt it. You ask it what you want in your native tongue. This allows anyone, anywhere, to become a programmer.
So to wrap up, we're seeing this shift from simple pre-recorded software to genuine reasoning agents. And that shift is supported by the largest physical build-out in history.
And it's leading to a future where we literally manage digital intelligence right alongside our human employees.
That comparison of AI to electricity leaves one big lingering question, though. If intelligence becomes a utility, what happens to a nation that refuses to build its own power plant?
Do they just get left in the dark? Or worse, do they become completely dependent on the nations that did build the grid?
Something to think about. Thanks for listening to The Deep Dive.